Mission highlights. The first 2 days, the crew ran into a couple of minor surprises, but generally, Apollo 13 was looking like the smoothest flight of the program. At 46 hours, 43 minutes, Joe Kerwin, the Capcom on duty, said, "The spacecraft is in real good shape as far as we are concerned. We're bored to tears down here." It was the last time anyone would mention boredom for a long time. At 55 hours 46 minutes, as the crew finished a 49-minute TV broadcast showing how comfortably they lived and worked in weightlessness, Lovell stated, "This is the crew of Apollo 13 wishing everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius, the LM, and get back for a pleasant evening in Odyssey, the CM. Good night." 9 minutes later, oxygen tank number 2 blew up, causing number 1 tank also to fail. The Apollo 13 command module's normal supply of electricity, light, and water was lost, and they were about 200,000 miles from Earth. The message came in the form of a sharp bang and vibration. Jack Swigert saw a warning light that accompanied the bang and said, "Houston, we've had a problem here." Lovell came on and told the ground that it was a main B-bus undervolt. The time was 2108 hours on April 13th. Next, the warning lights indicated the loss of 2 of Apollo 13's 3 fuel cells, which were the spacecraft's prime source of electricity. With warning lights blinking on, 1 oxygen tank appeared to be completely empty, and there were indications that the oxygen in the second tank was rapidly being depleted. 13 minutes after the explosion, Lovell happened to look out of the left-hand window and saw the final evidence pointing toward potential catastrophe. "We are venting something out into space," he reported to Houston. Jack Lausma, the Capcom, replied, "Roger, we copy you venting." Lovell said, "It's a gas of some sort." It was oxygen gas, escaping at a high rate from the second and last oxygen tank. The first thing the crew did, even before discovering the oxygen leak, was to try to close the hatch between the CM and the LM. They reacted spontaneously, like submarine crews, closing the hatches to limit the amount of flooding. First Jack, and then Lovell, tried to lock the reluctant hatch, but the stubborn lid wouldn't stay shut. Exasperated, and realizing that there wasn't a cabin leak, they strapped the hatch to the CM couch. The pressure in the number 1 oxygen tank continued to drift downward, passing 300 psi, now heading toward 200 psi. Months later, after the accident investigation was complete, it was determined that when the number 2 tank blew up, it either ruptured a line on the number 1 tank or caused one of the valves to leak. When the pressure reached 200 psi, the crew and ground controllers knew that they would lose all oxygen, which meant that the last fuel cell would also die. At 1 hour and 29 seconds after the bang, Jack Lausma, then Capcom, said after instructions from Flight Director Glenn Lunny, "It is slowly going to 0, and we are starting to think about the LM lifeboat." Swigert replied, "That's what we've been thinking about too." Ground controllers in Houston faced a formidable task. Completely new procedures had to be written and tested in the simulator before being passed up to the crew. The navigation problem had to be solved, essentially how, when, and in what attitude to burn the LM descent engine to provide a quick return home. With only 15 minutes of power left in the CM, Capcom told the crew to make their way into the LM. Fred and Jim Lovell quickly floated through the tunnel, leaving Jack to perform the last chores in the command module. The first concern was to determine if there were enough consumables to get home. The LM was built for only a 45-hour lifetime, and it needed to be stretched to 90. Oxygen wasn't a problem. The full LM descent tank alone would suffice, and in addition, there were 2 ascent engine oxygen tanks and 2 backpacks whose oxygen supply would never be used on the lunar surface. 2 emergency bottles on top of those packs had 6 or 7 pounds each in them. At LM jettison, just before re-entry, 28.5 pounds of oxygen remained, more than half of what was available after the explosion. Power was also a concern. There were 2,181 ampere hours in the LM batteries. Ground controllers carefully worked out a procedure where the CM batteries were charged with LM power. All non-critical systems were turned off, and energy consumption was reduced to a fifth of normal, which resulted in having 20% of our LM electrical power left when Aquarius was jettisoned. There was one electrical close call during the mission. One of the CM batteries vented with such force that it momentarily dropped off the line. Had the battery failed, there would be insufficient power to return the ship to Earth. Water was the main consumable concern. It was estimated that the crew would run out of water about 5 hours before Earth re-entry, which was calculated at around 151 hours. However, data from Apollo 11, which had not set its LM ascent stage crashing into the moon as in subsequent missions, showed that its mechanisms could survive 7 or 8 hours in space without water cooling. The crew conserved water. They cut down to 6 ounces each per day, a fifth of normal intake, and used fruit juices. They ate hot dogs and other wet-packed foods when they ate at all. The crew became dehydrated throughout the flight and set a record that stood up throughout Apollo. Lovell lost 14 pounds, and the crew lost a total of 31.5 pounds, nearly 50% more than any other crew. Those stringent measures resulted in the crew finishing with 28.2 pounds of water, about 9% of the total. Removal of carbon dioxide was also a concern. There were enough lithium hydroxide canisters, which remove carbon dioxide from the spacecraft, but the square canisters from the command module were not compatible with the round openings in the lunar module environmental system. There were 4 cartridges from the LM and 4 from the backpacks, counting backups. However, the LM was designed to support 2 men for 2 days and was being asked to care for 3 men for nearly 4 days. After a day and a half in the LM, a warning light showed that the carbon dioxide had built up to a dangerous level. Mission Control devised a way to attach the CM canisters to the LM system by using plastic bags, cardboard, and tape, all materials carried on board. One of the big questions was how to get back safely to Earth. The LM navigation system wasn't designed to help us in this situation. Before the explosion, at 30 hours and 40 minutes, Apollo 13 had made the normal mid-course correction, which would take it out of a free return to Earth trajectory and put it on a lunar landing course. Now the task was to get back on a free return course. The ground computed a 35-second burn and fired it 5 hours after the explosion. As they approached the moon, another burn was computed. This time, a long 5-minute burn to speed up the return home. It took place 2 hours after rounding the far side of the moon. The trip was marked by discomfort beyond the lack of food and water. Sleep was almost impossible because of the cold. When the electrical systems were turned off, the spacecraft lost an important source of heat. The temperature dropped to 38 degrees Fahrenheit, and condensation formed on all the walls. A most remarkable achievement of Mission Control was quickly developing procedures for powering up the CM after its long cold sleep. Flight controllers wrote the documents for this innovation in 3 days instead of the usual 3 months. The command module was cold and clammy at the start of power-up. The walls, ceiling, floor, wire harnesses, and panels were all covered with droplets of water. It was suspected conditions were the same behind the panels. The chances of short circuits caused apprehension. But thanks to the safeguards built into the command module after the disastrous Apollo 1 fire in January 1967, no arcing took place. The droplets furnished one sensation as we decelerated in the atmosphere. It rained inside the CM. 4 hours before landing, the crew shed the service module. Mission Control had insisted on retaining it until then because everyone feared what the cold of space might do to the unsheltered CM heat shield. Photos of the service module showed one whole panel missing and wreckage hanging out. It was a sorry mess as it drifted away. 3 hours later, The crew left the lunar module Aquarius and then splashed down gently in the Pacific Ocean near Samoa.